Termites nest. It can be a mutualistic or parasitic relationship based on the situation. The first one is mutualism, nutrient recycling, a type of symbiotic relationship where both organisms involved benefits from the interaction. The second one is mutualism, ecosystem support. Termites helps break down the cellulose in the wood, which is a difficult to ingest plant material. By decomposing the woods, termites facilitate nutrient cycling, returning vital nutrients back into the soil, benefiting other trees surrounding them.
Next is the symbiosis relationship between bird's nest fern and the tree. So their relationship is commensalism. Commensalism is a type of symbiotic relationship where one organism benefits while the other is neither helped or harmed significantly. Bird's nest fern grows on the branch of a tree as a physical support, while from the tree's perspective, it is not harmed by the presence of the bird's nest fern as it does not penetrate the tree's bark or take nutrients from the tree itself.
Rosea pilosolites, which is a dreaded scale fern, not a typical parasite but can be a facultative male hemiparasite. This is because the root hairs need to connect the vascular tissues of the host plant. No, the roots are specialized like Hausaria, and therefore differ from the roots of parasitic plants. Roots of some plants of Arachia penetrated into host trees. It is possible that some epiphytes absorb water and nutrients by penetrating the roots into host trees and are facultative male hemiparasites. Facultative parasitism. Facultative parasite is an organism that may resort to parasitic activity but does not absolutely rely on any host for completion of its cycle.
Next, this is a fungus. First is a motorism. Second is obligation symbiotic. This happens when an organism cannot survive in the absence of the another partners. Last, mycorrhizae. Mycorrhizae is association between fungus and root plant. You can see the mushroom is on top of the tree branch. Tree branch supplies energy through photosynthesis to fungi, and fungi take up the mineral nutrient from the soil. Then, fungi will transport the mineral nutrient into the plant roots.
Next is parasitism. Parasitism is a type of symbiotic relationship where the organism benefits at the expense of another organism. When termites cause significant damage on the tree by feeding on it, the relationship is considered as parasite. The termite benefit by obtaining food and shelter, but the tree is harmed by the loss of its structural integrity.
Assalamualaikum, my name is ZAINOL and I will explain about practical 1, which is a basic concept of statistic and variation. This practical, we have been learned about normal distribution and its parameter, the mean and variance, and initial understanding about a correlation. So the objective of this practical are to calculate and describe the following distribution with its mean, variance, and standard deviation. Next, to understand the concept of correlation, and lastly, to determine the relationship between two variables. So the material that we use in this practical is just leaf, ruler, word balance, and graph paper. The method that we use in this practical is we take 10 leaf, measure and record their length and width, and then we calculate the mean, variance, and standard deviation of the length and the width of the 10 leaf, and then we record the data in the graph paper. Next, we take another 10 leaf and repeat as above. We do this for another 3 sets of leaf. This is example how we record our length and our width. So here is the data for set 1 left leg. We got mean 22.71, variance 8.601, and standard deviation is 2.933. Next is a data for set 1 left right. We have mean for 6.410 and variance for 1.6832, and standard deviation is 1.2974. And lastly is the data for set 1 left leg. We got mean is 2.468 and we got variance for 0.8271 and standard deviation is 0.906. Next, we move to the data set 2 for the left leg. Mean that we got is 21.34, variance is 12.6249, and standard deviation is 3.5532. This is the data for the left right set 2. The mean that we got is 5.43, variance is 2.8761, and standard deviation is 1.6959. The data for the left wing for data 3, the mean that we got is 2.21x, variance is 0.6814, and standard deviation is 0.8255.
My name is MAISARAH, and I'm going to explain about set 3 and also the graph, and the last one is the question, post-lab question. So the result for set 3, A, leaf length. So we got the data as shown in the table. And for the mean, we got 22.53. For the variance, we got 3.8357. And the standard deviation, we got 1.9585. For B, which is leaf width, the data we got is shown in the table. So for the mean, we got 5.21. For the variance, we got 1.0077. And the last one is standard deviation, we got 1.0038. And for C, which is leaf width, the data is shown in the table. So for the mean, we got 2.462. For the variance, we got 0.8769, and the standard deviation, we got 0.9364. This is the graph that we got after we plotted it from the data that we got. So the distribution of the graph is more to the right side of the graph, which is between 15 until 30 for the width, and for the length, which is between 4 until 8 centimeters. For the post-lab question, the first one is discuss the differences or similarity of the mean of length between different sets of leaves. Do the same for the mean of width. So for the answer, the mean length of set 1, which is 22.71, and set 2, which is 21.34, are relatively close, with a difference 1.37 units. Meanwhile, the mean length of set 1, which is 22.71, and set 3, which is 22.53, with a difference of only 0.18 units. Next, the mean length of set 2, which is 21.34, and set 3, which is 22.53, with a difference of 1.19 units. Overall, the mean lengths across all three sets are quite similar, indicating that the leaves are from the same species with slight variations in their growth condition. After that, the mean width of set 1, which is 6.410, is higher than set 2, which is 5.43, and set 3, which is 5.21, by 0.98 units and 1.20 units respectively. Although set 1, set 2, and set 3 is the same species, the observed differences in mean of which can be attributed to several factors like environmental factors. And 2. What is meant by variance? The leaves have different measurements of width and length. What is the meaning of this statement? Discuss with respect to variance. What is meant by standard deviation? Answer. Variance is a statistical measure that quantifies the degree of variation or dispersion of a set of data points. It indicates how much the individual data points differ from the mean, which is average of the data set. The leaves have different measurements of width and length. It means that there is variability in the dimensions of the leaf. This variability can be quantified using variance, either high variance or low variance. A high variance means that the data points are spread out widely around the mean, while a low variance indicates that the data points are closer to the mean. Standard deviation is another statistical measure related to variance. It is the square root of the variance and provides a measure of the average distance of each data point from the mean. Standard deviation is expressed in the same units as the data, making it more interpretable than variance. Why is it necessary to have different sets of measurement for the measurement of leaf width and length? Having different sets of measurements for leaf width and length is necessary for a variety of reasons. First, it helps in capturing the natural variability in leaf size caused by genetic variation within the same species, as well as the effects of environmental factors such as light, water, nutrients, and temperature. By measuring numerous sets, we may see how this variable influence leaf growth and uncover patterns or relationships. Furthermore, several sets of data increase the reliability and correctness of statistical analysis. Single measurements may not reflect the full population of leaves, but numerous sets provide a more complete picture, allowing for precise variance and standard deviation calculation, which are critical for understanding leaf size distribution and dispersion.
Assalamualaikum and a very good evening to Madam Shazali. My name is NELISA and I will be continuing our presentation from now on. So for practical 2, we did an experiment to find out the factors that affect the distribution and abundance of organisms. The objective of this practical are to introduce the simple concept of quadrat, to enhance the power of observation, to record the difference in plant distribution with the quadrat, and also to infer from natural observation the possible factors that affect distribution and abundance of organisms. How exactly did we do this experiment is we measure up 2 meters of the length and the width of the area that we want to observe, and then we divide them by half twice so that we have 4 different areas on this quadrant, and then we identify each species of the plants that we found on the areas, and we count up their total numbers of individual and we record it in our results. As you can see here, this is our result, the drawing of our results. There are 4 different areas here, and each shape signifies different type of species. So the more abundant they are, the more shape they are drawn on this paper here. Next, as you can see in the table, the shape are aligned with different type of species, and as we can see here, the highest total numbers of individuals are Kimbopagan citratus, which also has the highest density amongst all of other plant species in the first quadrant.
So here we can see the picture shown here is the quadrant of the site, that is K. Each symbol represents a different species. In the observation, the first species we got is Photophylla villosa, which has total number of individuals 77. With a density of 38.20%, it indicates a preference for conditions that support its growth. This species likely thrive in areas with sufficient light and soil moisture, which are crucial factors influencing in distribution. The second species is Sprobolus dianthus, which has total number of individuals 22. The first count of Sprobolus dianthus reveals a density of 10.95%. This species presents suggests adaptation to specific microhabitats or disturbance regimes, demonstrating its ability to occupy niches influenced by factors such as soil composition or periodic disturbance.
Is ALIFAH ILYANA binti SAHARODIN. We present about answer for the question, the practical 2. First, a quadrant is a small or a square area using two sampling vegetations or another organism in ecology study. Quadrants are employed in a various sampling technique, such as quadrant sampling or a plot sampling, to obtain quantitative data or a species composition, abundance, and distribution. Second, two basic requirements of all the quadrant technique. First, the area of a quadrant counters, and second, the number of organisms of species in the quadrant. Surface is done a smaller quadrant. There is advantage and disadvantage. Advantage for the smaller quadrant. First, means calculate the species of sedentary organism. Second, less time consuming. For the disadvantage, first, quadrants law of accuracy of a species or means to many individuals that can result in under-representative estimates of the population size. Second, we can be complicated to be carried out and time consuming to test and sample. Four, first, is accessibility coverage. Larger forest area or crowded habits may be difficult to access as a content dense vegetation, rock stress, or deep water. For the next, would be visibility and detection. In a larger environment with a plant harrow of plantation, organism may be hidden below the dense patch of a coral. This will lead to low detection probability. There is a method temporary scala, seasonal variations, animal movement can affect the density estimate. And then repeat sampling over different time necessarily. Repeat sampling over different time is necessary capture this dynamic. Let's answer for this question. The difference in the number of plant species in the quadrant could be aftermath a few causes. The cause are this. Variations in soil composition, pH, and texture. Another cause will be the competition is like water and nutrient. Competition can lead to dominance by certain species in some quadrant and surprise for another. For the next, seed dispersal. The mode of the seed dispersal and effect where a plant is stubborn. Quadrant located near seed, so will likely have a higher species richness. Then the factor that may have a causality of distribution is abiotic factor, which are soil nutrient, pH, light, intensity, temperature, and another cause. They are also biotic factor, such as a competitive for resources, area presence, if intensive species, different mechanism have history and successional factor to qualify as the reason.